So here is another question. So it is given that a car moving with a velocity of 30 meter per second is stopped by the application of brakes which impart a retardation or deceleration of 6 meter per second square to the car. And then it has been asked to find out how long does it take for the car to come to a stop, which is basically the time required for the car to come to rest, and how far does the car travel during the time the brakes are applied. After that, from the moment the brakes were applied, how much distance it traveled further, okay, from that point. Okay, so let us say this whole situation, a car is traveling with a velocity of 30 meter per second. It is traveling and reaches this spot here. And here, for a particular reason, the brakes are applied. At this moment also the velocity is 30 meter per second. At this point, brakes were applied. And because of the application of brakes, the car started decelerating, slowing down, and it finally came to rest at this point. So here rest means 0 meter per second, and here the car came to rest. Now it has been asked to find this distance, okay, which the car traveled from the instant the brakes were applied. The brakes were applied at this point, it started decelerating and slowing down, and it came to rest here. Here the initial velocity for this entire thing, this is the initial velocity. Okay, this is the initial velocity, this is the final velocity, okay, and here the acceleration is given that it is decelerating, retardation, so it will be minus 6 meter per second square, the acceleration. Why the minus sign? Because here it is given that it is offering a retardation because of the application of brakes. Retardation or deceleration means this. Okay, so basically it is deceleration, not acceleration would not be the right word to say. Negative acceleration is deceleration or retardation. Okay, so A is equal to minus 6 meters per second square. If it would have been acceleration, then it would have been plus. Acceleration is positive. Okay, acceleration, it supports motion. Okay, it supports motion, it increases the velocity. Retardation or deceleration or negative acceleration, it slows down, it opposes motion. Okay, this, and that's why here the sign is negative. So first we'll determine the time required. Okay, we'll determine the displacement or the distance traveled later. So here first we'll determine the time. So here we'll be using the formula, the equation of motion, V is equal to U plus AT. Okay, here. So here final velocity is known, 0 meter per second, the car came to rest. Initial velocity is known, it is 30 meter per second. Acceleration is known, it is minus 6 meters per second square. So it is basically 0 is equal to 30 minus 60. That implies 6 t is equal to 30. That implies t is equal to 5 seconds. 30 by 6, which is equal to 5 seconds. So the car took 5 seconds from the moment brakes were applied to come to rest, to come to a stop. Now, in order to determine the distance which it has travelled, we will be using the formula v square minus u square is equal to 2as. Here v is equal to 0, initial velocity u is equal to 30, and this is 2 into a is equal to minus 6. It is deceleration or retardation, that's why it is minus 6 into s. So that is equal to, the s is equal to minus 30 square into minus 2 into 6. Negative and negative got cancelled in both the numerator and denominator, and this becomes minus 30 square by 12, or minus 12 or 30 square by 12, which is equal to, it is coming around 75 meters. Okay, 75 meters. Okay, this. So here it is, the question here which was given, it was based on the concept of negative acceleration or deceleration. So here again it was very simple and straightforward. All we had to do is to use our common sense to determine, first, from the moment the brakes were applied, the car will come to rest. So rest means 0 meter per second, that is the final velocity. Initial velocity is the velocity at the moment of application of brakes. Once we got the final velocity and initial velocity, we are already given with the negative acceleration value, the retardation value, which is minus 6 meter per second square. So it was very simple and straightforward to use the equations of motion. We use this v is equal to u plus at to determine the time. After we got the time, we use this formula v square minus u square is equal to 2s to determine the displacement. Here we could have also used s is equal to ut plus half at square. Okay, that way also we would have got the same result. See, u is how much? 30 initial velocity, 30 into how much? 5, time is 5. Here minus 1 by 2 into acceleration is 6 into how much? T is 5 square again. So it is 3. So here it is 150 minus 25 into 3 is 75, which is equal to 75 meter. So either way would have got the same result, that is s is equal to 75 meters. Whether you use this equation, v square minus u square is equal to 2s, or s is equal to ut plus half at square. Okay, yes. So here is another question. It is given that on a foggy day, two car drivers, they spot each other when they are just 80 meters apart. The gap between them is 80 meters. They are traveling at 70 kilometers per hour and 60 kilometers per hour respectively. Okay, the first one is traveling at 70, the other one is traveling at 60, and they are heading straight towards each other. Okay, both of them, they applied brakes at the same time, okay, simultaneously, and they suffered deceleration or retardation at the rate of 5 meters per second square. Okay, now we have to determine whether they avoided collision or not, whether they collided or not. Okay, so here let us try to understand the situation. Okay, two cars we have, they are traveling in the opposite direction towards each other. This is, let's say, car A, and this is another car B. it is traveling at how much? 70 kilometers per hour. So if we convert it into meter per second, it becomes 70 into 1000 by 3600. Okay, it is coming around 19.44 meter per second. Why I am converting into meter per second? Because the gap between them is 80 meters, it is given. B is traveling at 60 kilometers per hour, again converting into meter per second to 1000 by 3600. It is coming around 16.67 meters per second. So they are traveling in this direction. Just when the gap between them is 80 meters, they applied brakes. Okay, they applied brakes. So obviously when they will apply brakes, they will travel a certain distance and then they will come to halt. Okay, they will stop, they will come to rest. Because of the application of brakes, both the cars, they got decelerated at the rate of minus 5 meter per second square. Okay, this one also, this one also. So we have to determine whether they avoided collision or not. So let us see. We have to here determine how much distance each of these cars traveled after the application of brakes. Okay, how much distance they traveled. So we have to determine SA and SB. So here for car A, okay, for car A, initial velocity is 19.44 meter per second. Final velocity is 0 meter per second because it will come to rest, it will come to stop because of the application of brakes. Acceleration is minus 5 meters per second square. So here we will be using this formula, v square minus u square is equal to 2as. So here v square is equal to 0 square, u square is 19.44 whole square, 2 into minus 5 into s. That implies s is equal to 0 square minus 19.44 whole square by 2 into minus 5, which is equal to, it is coming around 37.79 meters. Okay, so here SA, this is SA, okay, VA square minus UA square by 2A SA. So here SA is 37.79 meters. It means the car A, it traveled a distance of 37.79 meters before coming to rest. Let's say at this point it came to rest, car A. Similarly, for car B, okay, for car B, the initial velocity is equal to 16.67 meters per second. The final velocity is 0 meters per second. Acceleration is same for both, retardation, that is minus 5 meter per second square. Same formula, VB square minus UB square equal to 2AB SB. That implies 0 square minus 16.67 whole square is equal to 2 into minus 5 into SB. So we have to determine SB, the distance travelled by car B, which is equal to minus 16.67 whole square by 2 into minus 5, which is equal to, it is coming around 27.79 meters. So here car B, it traveled around, let's say up to this point, 27.79 meters, and it came to rest here, okay, at this point, and this came to rest here at this point. So here if we calculate the the sum of these two distances that are traveled by car A and car B, that is SA plus SB, equal to 37.79 meters plus 27.79 meters, that is equal to 65.58 meters, okay. And if we subtract the initial separation from the moment when the brakes were applied, the initial separation was 80 meters. So 80 meters minus 65.58 meters, that is equal to 80 minus 65.58, 14.42 meters. So they came to rest, both of them came to rest while there was a gap of 14.42 meters between them. So obviously they did not collide. The collision was avoided, it was averted, the accident was avoided, because thankfully, because of the application of brakes, they came to rest, both the cars came to rest when there was a gap of the separation of 14.42 meters between them. Okay, so yes, they did not collide and the collision was avoided. Okay, this. Okay, this. So a very good question, where we had to use a lot of the equations of motion were used, but basic common sense was used. Okay, so first we determine the distance traveled by each of these vehicles after the application of brakes using v square minus u square is equal to 2as, and then we determined whether the initial separation and the distance traveled by both of them after the application of brakes, the sum of those two distances, whether it is lesser than the initial separation. So here it is lesser than the initial separation, 65 is lesser than 80. So yes, for that reason the collision was avoided. Okay, this. If it would have been greater than that, if the distance traveled would have been greater than that, then the collision cannot be avoided, they would have collided with each other, accident was inevitable. Okay.